Hey everyone, welcome to this quick explainer. We're going to help you perfectly revise acidic, basic, and neutral substances for your upcoming exams. I know. Chemistry revision can feel a bit overwhelming sometimes, right? But today, we're going to make it super simple, highly visual, and actually easy to remember. So whether you're tackling this for the first time or just doing a rapid brush up before test day, you are exactly where you need to be. Let's just dive right in.
Okay, picture this. You're at a science fair. Someone sprays a totally clear liquid onto a blank white sheet of paper and bam! A bright, hidden welcome message just magically appears out of thin air. How does that happen? Is it magic? Well, nope, it's chemistry. And it has literally everything to do with the substances we're going to master today.
Here's our game plan for today. We'll hit 5 key areas. First, the magic of indicators. Second, acids, bases, and neutral substances. Third, neutralization reactions. Fourth, science and daily life. And finally, a quick exam recap.
All right, Section 1, the magic of indicators, unlocking the secret colors.
Just like a curious student working away in the lab, we can use specific substances to reveal the hidden, invisible nature of everyday liquids. See, you can't just look at a glass of clear liquid and automatically know if it's an acid or a base, right? It just looks like water. We need a little helper to reveal its true identity. And that brings us to a massively important exam definition you definitely want to jot down: acid-base indicators. These are simply substances that show different colors in acidic and basic solutions. You can think of them kind of like chemical detectives. They literally change their coat color depending on the neighborhood they're visiting.
Now, what's super cool here is that we don't always need fancy manufactured chemicals to pull this off. For your exams, remember that nature gives us some brilliant natural indicators. You've got to remember these specific ones: lichen, red rose, red hibiscus, purple cabbage, and even the turmeric straight from your kitchen. Any of those can act as our chemical detectives. Moving right along to Section 2, acids, bases, and neutral, categorizing the world around us. Let's break this down by comparing 2 main groups. Think about Group A, things that taste sour, right? Like lemon juice, tamarind, and vinegar. These will turn blue litmus paper red. We call these acids. Then on the flip side, we have Group B. These are things that feel kind of slippery or soapy, like soap itself, baking soda, or lime water. These substances turn red litmus paper blue. We call these bases. As you're visualizing adding drops of these solutions to those little red and blue litmus paper squares, I want you to memorize this golden rule. Actually, say it with me in your head. Acids turn blue litmus red, and bases turn red litmus blue. Seriously, if you lock in that one simple color rule, you just secured some incredibly easy marks on your test.
But wait, science is all about asking, what if, right? What about tap water, or a sugar solution, or salt water? You take your dropper, you put it on the red litmus paper, nothing. You put it on the blue litmus paper, and again, absolutely nothing. Neither paper changes color. So what's going on there? Well, that leads us perfectly to another crucial definition: neutral substances. These are substances that are neither acidic nor basic, and because of that, they do not change the color of either litmus paper. They are completely balanced.
Okay, on to Section 3, neutralization reactions, finding the balance. So we know about acids and we know about bases. But what happens when they actually meet face to face in a beaker? An epic microscopic battle happens, a neutralization reaction. Here are the steps. Step 1, mix acid and base in sufficient quantity. Step 2, they cancel each other out to form a totally neutral solution of salt and water. And step 3, the evolution, or release, of heat. If you touch the outside of that beaker, it would actually feel physically warm. Listen to this chemical word equation you absolutely need to memorize. Acid plus base gives salt plus water plus heat. The key takeaway? That final mixture is completely neutralized. Burn this simple equation into your brain. It's a guaranteed point score on exam day. Next up, Section 4, Science in Daily Life, Real-World Neutralization. Let's step out of the lab for a second. Imagine this. A student named Kirthi was peacefully observing a beautiful butterfly out in the garden when, ouch, a red ant suddenly bit her. It leaves this angry, red, stinging mark. I mean, we've all been there. It really hurts. But Kirthi's brother? He knew his chemistry. He ran inside and applied moist baking soda straight to the bite. Here's the science behind the ant bite remedy. An ant's sting injects a highly acidic liquid right into your skin. Because baking soda is a base, applying it neutralizes the sting and instantly relieves the pain. Science literally to the rescue.
Finally, Section 5. Quick exam recap in a nutshell.
Let's do a rapid-fire review to lock all this in. Remember, substances are acidic, basic, or neutral. Acids turn blue litmus red, bases turn red litmus blue. And here's a fun fact for those tricky multiple-choice questions. Red rose extract is red in an acid, but it turns green in a base.
And whatever you do, don't forget our core reaction. Acid plus base forms salt, water, and heat. That single equation explains so much, from your lab experiments all the way to that awesome baking soda ant bite trick we just talked about. Now you are completely ready to revise this chapter quickly and totally ace those exams. But before you go, let's see if you can connect the dots with a fun question. If a mystery liquid turns red rose extract green, can you predict exactly how it would react to an acidic ant sting? Think about the steps, find the balance, and good luck with your studying.